Hello, physics kids. Mr. C here. To start off the first lab of the semester, we're going to be doing our conservation of energy lab. And the way that this lab works is we have our washer here. I'm going to pull it up and release it from some Y2 that I'm going to keep constant the entire time. It's going to come down here, swing down. It's going to hit the razor blade, cut off, or the string is going to get cut, and the washer is now going to fly across the table and land down here. I'm going to need to make 3 measurements. The first measurement is going to be the measurement of the washer, and we're going to call that Y1. So it's just going to be from the surface of our table up to the bottom of our washer. And once again, this is going to stay constant the entire time. We're going to keep it the same. We're going to make sure it's in the same position.
The time is 5:45. The late activity buses are at the pool entrance at this time. Please make your way to the buses. This will be the only call for the late evening bus. And have a good evening.
If you're riding the bus now, have a wonderful time. The second measurement we're going to take is Y2, and that's going to be from the bottom of the washer to the table from where we dropped the washer. And we're going to drop it from the exact same point at every time as well. So Y1 and Y2 for this experiment is going to be the same. And then finally, we're going to measure the distance that the washer travels. That's going to go from right below the washer out to where it lands for the first time. And we're going to do a total of 3 trials in order to minimize error. We could do more, but honestly, I'm tired. You're probably all tired, and some of you might even be disappointed. You transfer out of my class, you get away from me, and you think to yourself, yes, he's finally gone, but what do you know? Not only 3 days into the semester, and you are already looking at my face again. You just can't get rid of me. You just can't get rid of me. It's great. I think it's great. Anyway, let's go ahead and get started so that we can all get finished with this lab. So, I'm measuring out Y2 with my meter stick now, and I put it here to the bottom of the washer because I'm going to measure all my distances to the bottom of the washer. And I see it's right at 22.25 centimeters. So I'm going to go ahead and record this as my Y1 as 22.25 centimeters. And that's going to stay the exact same. I'm going to make sure that the washer is always tied at the same point so that we don't have to worry about changing our Y1. The next step is I'm going to measure. So now we're going to measure out our Y2 and we're going to drop this washer from the same height each time. So I'm going to measure once again from the bottom of my washer and see that I am going to drop it from 28 centimeters. So every time my Y2 is going to be 28 centimeters. So now I'm going to pull my washer back to 28 centimeters. Right here. And I'm going to release it. It landed right here, so right at 19.5 centimeters. So we traveled 19.5 centimeters, and I'm going to record that under distance 1, so 19.5 centimeters. I'm going to go ahead and pause the video while I reset this. So now it's time for trial 2. So once again, I'm going to bring this back to about 28 centimeters. I'm going to release it, and it landed right here, right around 19 centimeters this time. I'm going to reset our setup one more time so we can take our third and final data point. It is now time for our third and final trial. I'm going to pull it back to 28 centimeters. Right about here. I'm going to release it. And I see it land right around 20 centimeters this time. We'll do 20.0 centimeters. So just in case you missed it or you can't see, I'll repeat all these numbers one more time. For our Y1, which is the distance between the ground and the point where the washer gets cut by the thread gets cut by the razor, that's Y1 is 22.25 centimeters. Y2 is the distance or the height that we're dropping the washer from, and that was 28.0 centimeters. And then finally for our three distances. So for our first trial, we got a distance of 19.5 centimeters. For our second trial, we got a distance of 19.0 centimeters. And for our third and final trial, we got a distance of 20.0 centimeters. We're going to use all of this data here in order to calculate and see whether or not conservation of energy was followed. There's some questions in the lab guide that'll help you walk you through whether or not how to figure out whether or not energy was conserved. Make sure you answer all those questions in your lab report. Just as a reminder for those of you who had this class first quarter, because I know it was a very long time ago, this will be a full lab report lab, so you should include a purpose or some sort of objective statement. You need to make sure you have a list of materials that you use for this lab, even if you did it virtually. You need to make sure that you have a procedure and a diagram of the experimental setup. The procedure should be in your own words. It should not be things that you copy and paste from the lab guide or from the internet. You also need to include at the beginning of your lab some sources of error that maybe could have involved or maybe could explain why energy wasn't conserved, if that's what we end up finding out, or what sources of error could have been in this lab, and then any useful equations that you'll need for the lab. After that, you'll want to make sure and do your data analysis. There's going to be no graph for this lab, which is really nice, so there's no graphing necessary. Make sure you answer the analysis questions too. I believe there are some questions at the end of the lab that I want you to answer. And then finally, the conclusion. Make sure you write a good conclusion. That should include numerical data, so anything that you calculate. I believe we're going to ask you to calculate speeds. We're going to ask you to calculate the theoretical distance. Make sure you compare those with the actual distances that we traveled. Make sure you talk about percent error in your conclusion. Make sure that you talk about sources of error in your conclusion. So just sort of reiterating what you said at the beginning of the lab, and also include a suggestion for improvement. So what could make this lab better? And sometimes it might be you're doing it in person. Maybe it's something that you saw that I was doing that wasn't right, but name a suggestion for the lab. And then I think that's all. I think that's everything. And also, make sure you restate whatever the objective is. So what is the purpose of our lab? If you have any questions, feel free to ask me, or you can ask OC. I'm sure she would be more than happy to help you out.